Hello everyone, my name is Piers Ridyard. I am the CEO of RDXWorks, and I have with us the founder of RDXWorks, Dan Hughes, and we're going to be answering some questions that we've been having in Telegram. Also, a very happy Christmas and happy New Year to everyone. This is the first of our videos after the Christmas period, which has been great. We've had some really good questions between our last one and now. We're going to be going through them in order, oldest first. A couple of them we're having to skip this time because they've literally referenced entire papers or websites which we haven't had time to read, so we will have to circle back to them at some point. But thank you very much for everyone's very good considered questions. So first question of the day is by Will. Is Radix going to support a decentralized DNS, domain name server, like ens.domains for ETH for Ethereum? Dan.
Wow, interesting question. I think when you take a long view, Web3 is the current buzzword, right? And how DeFi interacts with that and stuff, and identities and the locations of things and dApps and stuff. I think that, kind of decentralized domains, or at least decentralized resource and locating things and being able to go and retrieve them, I think is going to become very important over the longer term. Otherwise, how are you going to find anything, right? How are you going to be able to interface with, traditional browsers and stuff? You don't want to be having to use a specific Web3 browser to be able to go and find something, or use a dApp that you want to use or whatever. So I think these kind of alias identity systems, whether it's for people or for resources, objects, whatever, play a big role coming forward. And I really do like the whole kind of unstoppable domain stuff, that you can go and play with those, and you can point it at things and stuff, and it's really quite cool. And if you haven't looked at any of the tech on how that works, it's quite smart as well how they've done it, especially considering the kind of immaturity of this industry and Web3 tech and all that kind of stuff. It's quite ingenious. So I think that for us, Radix, we're going to have to also have similar things. Now, thankfully, this is something that we've been kind of thinking about for a long time, with the kind of resources and the resource locators and stuff, for a number of years now, actually. And some of you OGs will remember us playing around with ideas for this back in like 2013, 2014. So it's one of those things that kind of sits on the radar, but it's always also one of those things that's like, well, it's not a pants on fire thing that we need yet. So we'll just continue to consider it and look at what other people are building, and just kind of keep our eyes open on, okay, what is this doing? When are we going to need it? There's no point in us building it yet, because we don't have anything that could actually use it in terms of our own ecosystem. But I think that for us to not have it over the medium long term would be foolish, to be honest, or at least some interface into some protocol that does this, right? Maybe there's another one that's suitable, and it's not worth us building our own, so we just hook into that instead.
Yeah. So like there's sort of like there's the computer addressing problem first, as in like just how do you uniquely identify things on a ledger, and then there's the human readable to computer addressing problem, that we've been all of our thoughts have been around the computer addressing problem. That's where the ROIs are from and all this kind of stuff, and that will get more sophisticated over time. But I also say that like ENS is not a Ethereum project, as in it's not Ethereum Foundation project. It's a private project. It was thought about in 2015, and like it sort of took off then, and then it sort of disappeared, and it's only really coming now that like there's enough maturity and tooling and interfaces and all that kind of stuff that started to be useful. So like if people want to build decentralized domain name services on top of Radix, they absolutely can. Like our main focus is going to be on making sure that the computer addressing the lookups of things as effective as possible, so that your read writes are as easy as possible in the ledger. And DNSs will be built on top of that for sure.
Yeah, I think a DNS system as an external thing, right? So obviously you want to have you need to support some kind of people addressing or an identity addressable stuff internally, right? As well as all of your kind of computer addressing stuff. But I think that domain names, for example, I think that's always going to be an external service that pushes into a ledger, right? Like you wouldn't have that protocol running within the Radix protocol itself. It doesn't make any sense for it to be there. But what you potentially need are like hook points, right? So, okay, you want to come in through this endpoint if you're going to be coming from a particular, an ENS domain, for example. This is the API that you would hit with whatever it is you're looking for. So I think it would always be like a peripheral thing. ENS is one of them. There's lots of other good schemes as well. And if they don't satisfy what we need, then we'll have to build our own.
Yeah, but I mean, this is very much an area that we'd love to see sort of community sort of playing around with ideas, because I think that's where you get a lot of innovation coming out as well. Next question by SelectivePrime. Hello, Radix team. I ask myself how elastic Cerberus actually is. Elasticity defined here as a sudden increase in throughput, transactions per second need. As an analogy, imagine eBay. During an auction, most concurrent bids happen in the last 3 seconds, but many at the same time. So my question is, can Cerberus deal with spikes like that? If yes, what are the limits?
So I'm just going to generalize this, right? I'm not going to talk about it in purely as Cerberus, because you can generalize it and it still applies anyway. So there's a few things here that you want to first consider, right? So being able to handle spiky load, right? A sudden increase in throughput requirement. The first thing that you want to look at is, well, all of the validators that are processing these transactions, what is their baseline performance saturation, right? So if you've got, say you got 100 validators and their CPU is always at 90%, well, then you're not going to be able to handle very much additional spike, right? You forget everything else, forget bandwidth, forget storage. If your CPU is at 90% all the time, then you haven't got much scope to handle anything additional, right? So the first thing that you want to do in order to be able to enable these spiky events is, well, what we actually want is for the baseline of validators in the network to be as low as possible, right? That's like, optimizing the code, making sure that all of your algorithms are as efficient as possible, signature verifications and stuff. Make sure all that stuff's really efficient, right? And then let's say that you've got, you do that work, and then your validators, their baseline CPU consumption at, say 100 TPS, right? Whatever. Say that's at 20%, right? Now potentially you have the ability to handle 5 times spike for a short period of time, right? You can push the CPU up to 100%. Then your other considerations come into play as well. Okay, well, what's my baseline bandwidth, right? If I have a 100 megabit connection to my validators and they're constantly using 90 megabits, well, then again, I haven't got much available capacity to deal with a spike. So you do the same thing. Make sure that all of your over-the-wire communication is as simple as possible, right? You're compressing things you can compress, making sure that the data packets are optimized. You're not sending across information that's superfluous or you don't need it or whatever. So that's kind of your first step, right? Is, okay, how do you maximize the available resources that any set of validators has? Obviously, you're going to get some discrepancies between performance of validators and stuff. So even though some validators theoretically have like a 5x that they can spike up to, you're going to have some, it's not going to be a uniform hardware configuration across everything. So, maybe you can handle 2 or 3x of load for a short period of time, which is fine, right? Then you want to be thinking about your consensus mechanism. Yeah. So like in the case of Bitcoin, for example, the blocks are 1 megabyte, and the blocks are full. So Bitcoin can't deal with any spikes because, well, the blocks are always full anyway. So if any more comes in, they're just going to have to wait, right? So then you've got latency. You need to think about, okay, well, our transaction is going to time out. How much available bandwidth do I have left over in the consensus mechanism, whether I'm using blocks or proposals or whatever it is you're doing, right? If it's full all the time, then you're not going to be able to deal with any overpressure of throughput, right? So then you want to build in some capacity for spikes, right? If you're building a consensus mechanism and you're only thinking about the baseline, then you're going to have problems. If you need to think about allowing availability for things to get spiked, because things will get spiky. So in the case of like blockchains, you have a bigger block size, right? In the case of say more classical BFT stuff where you've got proposals and quorums and things like that, then you can either do batching into proposals or you can try and increase the number of rounds per second that you're doing. But there's no right way of doing this because it depends a lot on your consensus mechanism. What do the transactions look like? What does each transaction do? Are there any other potential like bottlenecks, right? Like execution bottlenecks and things for complicated smart contracts. As I'm sure many people are aware, projects that can do 10,000 simple state transitions per second, A to B payment transactions, can only do a handful of smart contract things a second. So it all depends on the workload and stuff as well. So
there's actually an interesting sort of extra point here around incentives as well, because the on Radix, the way that the incentive structure works is if you miss proposals, your block reward gets substantially reduced. So like if you're 100% proposals each epoch, then you get the full amount of the reward, as in like proposals that you've voted on, that you were eligible to vote on. I'm
not sure if that's relevant here though, right? Because this is talking about max available bandwidth. So like, let's say that all of your validators are not, they're not missing any proposals. They're just going as fast as they can.
Yeah.
And then a big chunk of additional transactional load comes in. Like whether they're missing proposals or not isn't really relevant.
Right, but if you're highly incentivized to make sure you never miss a proposal, then you're going to make sure you've got plenty of overhead. I assume the incentive would structure you to have plenty of overhead on your node to make sure that you don't max out CPU suddenly and then start missing proposals as a result of that.
Sure, but then you get into consensus land, right? Like I can run a Bitcoin node all day long and the CPU doesn't move from any above 10%, right? But I can't do any more throughput than what it's currently doing.
Right. So there's like the throughput of the network as your maximum, just because of consensus, but then you've got the throughput of the node. And if the network's running at 2 TPS and someone's is at 100% CPU on 2 TPS and it goes up to 50 TPS, you're going to start missing proposals.
But
so
if your network can only
to
consume 2 TPS anyway,
right?
That's it. Then it doesn't really matter. You can't throw any more in. So I mean, like there's not really an answer here because there will always be some load spike that you just can't accommodate, right? Always, you will run into issues. We will run into these things where something just oversaturates a set of validators, and it will either saturate I/O bandwidth, CPU, something will get saturated, and so some things will become latent for a period of time. And spikes are just, it happens, right? The best you can really do is just try and make those baselines as low as possible so that the individual machines locally have enough resources to be able to keep up, and to just optimize your consensus mechanism as much as possible so that you can deal with these spikes, right? So like for Babylon, we conservatively say 50 to 100 TPS is what it can handle, but there are places where the Babylon BFT consensus can be optimized, and there are elements of it that would actually accommodate a spike for a small period of time. We're quoting a constant baseline of 100, but that 100 can facilitate some spikiness, if you like. That's like, the safe benchmark. Yeah, this is where it's safe for a period of time. This is sustained. Spiky, yeah, maybe it can do 150, 120 for a small period of time. Then there are other techniques you can do as well. If we're getting these spikes that are saturating the network a lot, then there are optimizations that we can make and roll out updates for.
Right.
So
I think like until we're consuming 50 transactions per second consistently or spiking up to it consistently, like there are other things that can be concentrated on, but like these are certainly all relevant. You're constantly as a company, you're constantly thinking both about your existing technical debt and your future product roadmap, and you're balancing both things against each other.
Yeah, like with Babylon, we know that it can handle spikes of 150 because we've tested that, right? That was testing these things and making sure you've got margins for this stuff is a large part of the development process as well. We had many conversations about it. So we say 50 because that's what it can sustain for a long period of time and keep finality low. But we've tested multiples of that in terms of short-lived spikes.
Yeah, but I mean, let's move on to the next question, which is from Blindsight. Sushiswap case and what it teaches us about DeFi. So DeFi equals finance code run on top of decentralized infrastructure is basically what I defined it as, which is, Andre Cronje was saying, we should move away from the term decentralized finance and instead we should change it to something else like open finance or Web3 finance as a sort of more accurate, being that it's not always decentralized or often not decentralized. Where I was saying, well, the name change is unlikely. Like we've seen similar things just with, Radix isn't a blockchain, but like, what do you call it? And like, EU in the blockchain industry, that sort of blockchain has become the term of art, and it sort of describes everything, even though Radix is a decentralized ledger technology rather than a blockchain. DeFi is going to have a similar thing. However, my point was, I think that the important aspect is everyone is building on the same open network. And that's where the network effects come from. And you can have permissioned systems or quasi-permissioned systems or permissionless systems all on the same thing, but the assets are all in common. So, if I've got a stable coin on Ethereum, I can, and I'm also an institution, I can move it into Aave institutional product, and then I can move it out of Aave institutional product to a permissionless product. And I'm able to do that by nature of the fact that I, as an individual, have been verified, or my company has been verified and is able to access this product. But it's all built on the same underlying infrastructure, because what you want for the infrastructure is you want the infrastructure to be as decentralized and robust and secure as possible, to take away that issue of like the risk that the if the company went away, suddenly you wouldn't have access to your funds, or suddenly you wouldn't have access to your savings, or whatever it happens to be, right? So like the infrastructure being decentralized takes away a huge worry, a huge set of what is often called counterparty risk that exists in the finance system that we're able to remove. It doesn't, like, it adds other risks like smart contract risk, and absolutely a lot of decentralized finance products have master admin keys that mean that, like, from a true decentralization, like from a purity point of view, you could say, well, no, actually it's massively centralized because the admin key can go in and change anything and withdraw anything and update anything. But like,
the alternative to that, of course, is having a really complicated governance structure, which
Right. And like, this is part of what the whole Sushiswap drama has been, where people have been going, well, actually there's a small cadre of people who hold basically all of the power within Sushiswap, and it's not really decentralized. And I think that we talk about decentralization in the wrong context, in that decentralization is nuanced. Like, we want, like, the internet, you could say the internet is decentralized at a protocol point of view. Like, the protocol itself is just TCP/IP, but from the point of view of how we actually consume the internet. We consume it through centralized services. What we're trying to do is make an infrastructure that is as decentralized as possible for the representation of assets and the representation of value. But there are going to be many instances that you will interact with a centralized or quasi-centralized solution, or because of regulatory requirements or whatever. That's fine. Like, it's the fact that the infrastructure is decentralized and robust is the important thing, because it takes away so much risk that currently exists in the centralized system, in the fully centralized system.
There's always going to be pockets of centralization, but I think, like you say, the bit that matters is that the protocol underneath, the value transfer in this case, if you like, being able to transfer value from one place to another, that transport layer has to be decentralized. Everything else, you're always going to get pockets of centralization, right? Whether it's a company or it's a team of developers, right? You like, the development of Bitcoin is centralized because it's just a small group of developers that do most of the work, right? Sure, it's open source, but you're always going to have these pockets of control and decision making and centralization, and you'll never get around it. But the point is that a DeFi in that same sense is like, I've got a website hosted at Amazon, right? But I don't like Amazon anymore, so I can lift my website and I can put it somewhere else, and nobody can stop me from doing that, right? And this is the same thing here. I've got some value and I can move that value, right? Maybe to move my website from Amazon, I have to, pay a fee to cancel my SLA that I've got with them that I agreed, but I can still move it, right? I can still pick it up and I can move it somewhere else. And I think that's a point here, right? That moving my website is fine and people can still access it because the protocol is decentralized. And people don't need permission to go to my website in a new place, which is, I can move that value.
I think sometimes it's very easy to be a purist, like, where you're like, if it's not completely decentralized, it is absolutely centralized and there is no decentralization in it. It's decentralization sham. And it's like, it's just like, it's a too military, it's a non-practical view. It's a non-practical view. Like,
if that's your worldview, that everything built upon a decentralized, permissionless ledger of some kind, whether it's a blockchain, a DAG, or whatever it is, right? If your worldview is that the protocol and all the applications that live on top of that, all the service providers, everything must be 100% decentralized, then you're going to be in for a sharp wake-up call, because it's impossible to do that. It's impossible for everything to be decentralized in that way, because in order to do so, you would need some sentient AI to make decisions based on the fact that humans are shit at voting on things. Because after the 100th thing that comes to your phone to say vote on this, you're like, I can't be asked voting on this anymore. I've done 100 votes for things today. I don't want to vote anymore. Somebody else can do it. I'm here trying to watch Kardashians.
Switzerland, incidentally, has a direct democracy process and one of the highest suicide rates in Europe. Connected? I don't know. I actually don't know. But there's a lot.
Yeah,
there are pluses and minuses. Like, are you decentralizing the right thing? Do you understand where the nexus of trusts are? And and ultimately, are you delivering value to your user, and are you delivering value to the economy? Have you minimized the number of ways in which something can be attacked? Have you minimized the number of ways that it can be, you can be fraudulent in it, but still make sure that you're able to progress it and update it and change it so that you can build better products? Like, this is the constant battle. And it's sort of like it's another version of the battle between convenience and security, right? In the old Web 2.0 world, where you're like, you can either make it secure or you can make it convenient, but it's difficult to do both because
you can't do both. It's the same here, right? It's either completely decentralized and comes with a bunch of its own cons, right, or it's centralized to some degree and has a different set of pros and cons. And if you want to use an application within a decentralized infrastructure, emphasis being that the protocol that moves things around is decentralized, then you've got to make a choice, right? Which of those pros and cons do you want the most, and are you willing to take both of them? Are you willing to take the cons with the pros? But the point is, you've got a choice, right? I think that is the most powerful thing about these decentralized infrastructures is you've got a choice, and the choice is yours. And you can look at all of the available options, and you can make an informed choice, right? Whereas in the existing kind of status quo establishment, there are no choices. It's just you need a bank account. These are the rules. Boom. And all of the providers are the same because there's no real competition, because you need a $100 million banking license to go and play with the big boys there. So there isn't really any choices. Whereas here, there's a choice. I don't like the way you're doing things. So, well, move then, and you can move.
Right. And the decentralized infrastructure that holds your representations of capital allows you to do that.
Allows you to move pretty quickly as well. If if I don't want to use Uniswap anymore, I can very quickly move any tokens that I have somewhere else within a matter of minutes.
Mm-hmm.
Like, you try and move your bank account.
Try and send money from your bank account.
Oh yeah, just send money. Above 10 quid these days, you need to fill out a form. What are you buying?
Okay, so next question. Can we get an AMA on distributed crypto-safe random number generators? There are a whole class of applications that require such functionality. Games, for example, and technically this won't ever be safe for off-chain. And this won't ever be safe for off-chain or from a smart contract, and must be done on-chain. It's an interesting statement. Is Radix going to have an on-chain random number generator?
We can. I think if it's definitely going to be, you're going to need a random source of something at some point. There's no way around that. So there are really two classes of randomness when you're thinking about crypto, right? You've got just generated random values that can be proven to be over a sequence of time actually random. They're the easiest to produce. Then you've got verifiable random, where you have you get a random number, and then you're able to validate that random number was generated correctly. So you can't prove that it was random, and you can't prove the randomness of it, but you can prove that under the circumstances in which this number was generated, it met all the requirements, right? It was generated in the right way. There was no kind of fiddling around with the process that generated this number, and that's quite a bit harder to do. If you just want a random source, then there are many ways to produce that. I played around with some of this stuff quite a lot, especially with tempo, and without getting down a rabbit hole of how this kind of came about in tempo. There was a particular primitive in tempo we were using to validate the logical clocks. Some of you might remember from back in those days, I talked about kind of the logical commitment schemes that guarded the logical clocks. And anyway, it turned out that those commitment schemes, when passed through, there's a set of tools that you can pass a random sequence of numbers through, and it will tell you whether it meets some criteria of randomness, right? And so the output from these functions, we passed them through this set of tools, and it came back as this is essentially a random number for all intents and purposes, right? And these tools are, these tools are used to verify. You got a black box hardware that generates random numbers for things, or like seed generators that have to be very random. This same set of tools is used to verify that there is enough randomness in the output of these functions. And then that led into some other ideas around, okay, so random number generation is going to be important. And what really is the key that I used for tempo was the fact that you have non-deterministic latency between communications of validators, right? Mm-hmm. So even in a perfect network, me and you, my validator and your validator would see things at completely different times, even if they were sent to us immediately at the same time, right? So there's somebody else and they send a message to me and you at exactly the same time. Me and you will see them at slightly different times because speed of light, where you are on the planet, looking how many hops it's got to take to get to you, etc., right? And so even if that person was spitting out messages to us both, we would receive those messages out of order, right? So even in TCP/IP, what the internet runs on, the actual TCP protocol has a reordering algorithm, because you will get messages out of order to which I sent them, right? And so the random number stuff in Tempo kind of leveraged that fact, that a set of validators will see things in a grossly different order, which is why you need consensus mechanisms to give you partial or total order depending on what you're doing, right? Because people will see things in a different order even if they are sent at the same time. And so you can use these random properties of things, right? So the randomness of when I receive something versus somebody else, the randomness of when I execute something versus somebody else, the randomness of signature generation, all these kind of things. You can use all of these things, and collectively you can make quite strong random numbers. If you want verifiable random numbers, that's completely different kettle of fish. And I try to stay away from that because it gives me a headache. I mean, like, then you're stateless, right? Then you're stateful. So it's like, okay, how was this number generated? What were all the bits that were used to generate this number? How can we be sure that those bits that were used to generate this number were also valid and true, right? And it just becomes a bit of a rabbit hole. So if you need a verifiable random function, then there was quite a few of them out there already that are very good. So I would use them.
I think sort of like the short answer to this is like, if you're thinking about building something on Radix, like, don't wait for a random number feature of the underlying ledger. Either just find a good enough source in how the ledger already functions for your purposes, or use an oracle from an oracle provider, because those are the things that will allow you to build now. This is not something.
Yeah, I mean, like, if you want a random source from the Radix ledger, then you could get one that's probably sufficient for most purposes just from the quorum certificate, right? So right. The signatures of all the validators and what the proposal that they're validating with all the hashes and stuff, that will give you a fairly strong random number, right? Because it's a collective of random numbers, yeah. So the beauty about that kind of stuff is that let's say there was 100 participants, right, and 99 of them were dishonest, and they had agreed on a sequence of numbers to pick out of a hat to create this random number, right? All you need out of that 100 is one guy to actually pick a random number, and the number is random, right? Mm-hmm. So if you just want a strongish random number, then you could just basically take the quorum certificates, hash them, and then you can use that hash as a seed. If you want a truly strong random number, then you should probably pick something that some actual proper establishments that have done years of testing with it have put together, and not some hodgepodge version of a quorum certificate from a Radix ledger. But if you just need a source of randomness, then you could use the quorum certificates for some of that. If you want a verifiable random function, then I would definitely pick one up off the shelf. I wouldn't like to write a verifiable random function. It's one of those things, right? It's like, don't roll your own crypto. It's like, I understand the crypto, and could I probably write some crypto, like a new algorithm? Probably. Would I feel confident in doing so? No.
There's a difference between can you do something and should you do something.
Yeah. And do I want to, right? Can I and do I want to? Can I? Probably. Do I want to? No.
We have time for one more question, which we've got 4 minutes left on the clock. Is it possible, so this is a question from Maximum, is it possible a heavily targeted spam attack pointing at one address could potentially cause a problem? Target validator set transaction per second is around 1,000 transactions per second, if I recall, which would need $10 per second to spam into submission. Not feasible, not unfeasible if enough is at stake.
Right. So, yeah, this is where your kind of thinking is the wrong way around, right? So, as like most sharded platforms, ledgers, the Radix ledger isn't based upon account addresses, right? So account addresses are really just associations with state. So I wouldn't have a shard where my address lives and all my transactions live in that same shard. That's not how this works. What all the pieces of state, all of the transactions that I've received and sent from my wallet, my address, they're all distributed across the entire shard space. So if I try and just spam a particular address, then I'm just going to send transactions to all the different shards. So effectively, to kind of, for that attack to work, I've got to spam everybody, because there is no concept of an address shard, right? It's all of my transactions that are owned by my address, right? The inputs, the outputs, the sends, the receives, they're what matter. And if you send a bunch of bad transactions to a shard trying to spend state that doesn't exist, then all the validators in that shard will very quickly disconnect you, because they know that it's a obvious malicious attack, right? It's like, this guy's trying to spend stuff that we don't have and is not relevant to us, so disconnect, goodbye. So you can't just overwhelm the wallet, right? So you couldn't send tens of thousands of transactions per second at my wallet address, because my wallet address doesn't actually have a location in the Radix shard space. It's the state. The state transitions have an address.
That's definitely my fault. Like some of that, like because I always talk about addresses being the basis for addressing of state on the network, because it's easier shorthand than sort of like.
Well,
yeah.
Each state does have an address, right? Like it's an addressable thing, but that state address has nothing to do with who owns it.
Right. Which means that you're essentially load balancing the entire network.
Everything's
all of
load
the time.
balanced. Yeah. Very uniformly, in fact, as well.
Yeah.
Which is really interesting.
No, it's a really cool, like, it's one of those features where you're like when you get down to it and you like understand it, or when I got down to it and I understood it, I was like, that's so fucking cool.
Yeah, it's that auto load balancing is quite nice. So and like that kind of auto load balancing as well. You know, that's what will make things like, you know, spamming and stuff and DDoS attacks on particular applications or things. It makes it very, very difficult to do, because you essentially just have to spam the entire network to just bring down one application, pretty much, which is same as trying to spam my ability to transact on the network out of. There's not just a particular set of validators I have to go and kill to stop dancing in a transaction. It's I have to go and kill all validators.
Right. And then there's a bunch of like sort of network level rate limiting stuff and all this that sort of will help you there as well.
Yeah. Whereas, usually you just, those validators, those shard, that's where X number of accounts live. Blow them up. Okay. Bye-bye, whoever you are. It's not that easy. Awesome.
Well, it's been a really interesting AMA as always. We've got some questions we're going to have to circle back to. Thank you, everyone who put in a question over Christmas, and really looking forward to our next one, Dan.
Bye, guys. See you soon.
Cheers. Bye.